Grace and peace to you all, and welcome back to my channel. This is Donald C. I'm author of Hidden Mathematical Genius Within Revealed. Okay, so on today's video, we are going to apply gamma functions into integration. Okay, so that's our question. Evaluate I is equal to the integral from 0 to infinity of the fourth root of x multiplied by exponent of minus square root of x dx. Okay, so I believe you remember the definition for gamma function in terms of definite integral. There were three forms, but today we only focus on one form. So we are going to transform this integral into gamma function, that is integral definition, okay, into this. So if you look at our question, we have here our exponent has a minus square root of x. This is an expression. This expression here is supposed to be just a single variable. If you have seen here, we have exponent of minus t. It's just t, meaning a single variable. So what we do, we are going to let this square root of x to be any letter, and in this case, we'll just let it to be t. Okay, and try to transform into this. Okay, so say let t equal to square root of x. Then we make x the subject of the formula. So it's just a matter of square rooting both sides. So if you square root of x, you get x is equal to the square of t, that is t squared. Then we find dx. So dx is equal to the derivative of t squared will be 2t. This is with respect to t. So multiply by dt. So where there is dx, we are going to put 2t dt. And where there is square root of t, we put a t. So when you change the variables, you also change the limits, or you see if the limits have changed. So we had x from 0 to infinity, okay, changing to t. Okay, so if you put a 0 where there is x here, we can say that it will be a 0, because square root of 0 is just 0. So t will be from 0. Then if you put infinity, it will still be infinity, meaning the limits will remain unchanged. Okay, so I is equal to the square root from 0 to infinity of where there is x, we put t squared. And we know that this fourth root of x can be written as 1 over x to the power 1 over 4. And here we have a power of 2. Let me just say, where there is x, we put t squared. Then the fourth root, that is power 1 over 4. Then multiply by exponent minus the square root of x. Where the square root of x, we put a t. So minus t. Then where there is dx, we are putting 2t dt. Okay, now let us simplify. Okay, so I is equal to the 2 can come to the front here. So we are going to have 2, then integral from 0 to infinity. Okay, then 2 can go in 4, that would be 2. So we have 1 over 4. Then this t has power 1. So just a matter of adding the powers. So 1 over 2 plus 1, you get 3 over 2. So we're going to have t to the power 3 over 2. Then exponent of minus t dt. Okay. So now here we can see that this is now similar to the definition for gamma function, the integral, the definite integral definition. Okay, we have exponent of minus t. This is exponent of minus t, then t is to the power z minus 1. So it's just a matter of letting z minus 1 equal to 3 over 2. Then we solve for z. Okay, so we say z minus 1 is equal to this 3 over 2. So 3 over 2. Okay, so for us to remain with z, this is minus 1, so we are going to add 1 to both sides of the equation. So when you add the 1 will cancel out the minus 1. So 3 over 2 plus 1, you get 5 over 2. So z is equal to 5 over 2. And we know that this is just gamma of z. So I is equal to 2 gamma of z is 5 over 2. So gamma of 5 over 2. Okay, that is our answer, but we need to simplify it further. Okay, I'm sure you remember the first property where we said gamma of z plus 1 is equal to z gamma of z. And also we know that gamma of 1 over 2 is equal to square root of pi. So what we do is we are going to simplify this gamma of 5 over 2 to get gamma of 1 over 2. Now, how do we get gamma of 1 over 2? We are going to keep on subtracting with a 1. So if you subtract with a 1, the result you are going to multiply to the 2 here. Okay, so it will be like this. I is equal to 2 multiplied by 5 over 2 minus 1. You get 3 over 2. So 3 over 2. Again, we are going to have gamma of 3 over 2. Now we want to simplify it to gamma of 1 over 2. So again, you say 3 over 2 minus 1. 3 over 2 minus 1, you get 1 over 2. Then here we are going to have gamma of 1 over 2. So we have simplified. Okay, so what you do now here is that this can go there. So we say 2 in 2 is 1. In this 2 you get 1. So I is equal to, this is 1 multiplied by 3 multiplied by 1, you just get 3. 1 multiplied by 2, you get 2. Then where there is gamma of 1 over 2, you get square root of pi. Square root of pi. So that is our answer.